Today I want to talk to you about the keep, change, flip method of dividing fractions. Many of us have learned about this strategy, but do we really know why it works? Well, if you don't, you will after this video. Say you have a division expression with fractions. For example, 1/2 divided by 1/3. We know that if we keep the 1/2, change the operation sign to its inverse, so in this case divide would change to multiply, and flip the fraction in the divisor, or change it to its reciprocal, which would be 3/1, we can multiply straight across to get the answer. 3/2 or 1 1/2. Even though we know the method and we know it works to get you the correct quotient, we need to know why it works in order to use it. Let's start over by looking at our original expression. We know that the first fraction or number or first part of a division expression is the dividend. And we know that the second is our divisor. We also know that the dividend is the same thing as a numerator in a fraction, and the divisor is the same thing as the denominator. So what we're going to do is we're going to rewrite this expression in the form of a fraction. So I'm going to write my numerator as 1/2 and my denominator as 1/3. I think we can all agree that this fraction is crazy, and we need to simplify this somehow. Something else we always know, that anything divided by 1, is itself. The way we're going to simplify this fraction is we are going to set this fraction, the whole thing, over 1. So then we can just focus on the numerator instead of having fractions within fractions. Something else you also need to know is the reciprocal. The reciprocal is just when, like in keep, change, flip, when you flip the fraction. For example, if I flip 1/3, I get its reciprocal, which is 3/1. The cool thing about the reciprocal is when you multiply a fraction by its reciprocal, you always get a value that is equal to 1. And that's exactly what we are going to do here. We are going to set the denominator equal to 1 by multiplying by the denominator's reciprocal. So we're going to do 1/3 times 3/1, or 3 wholes, in the denominator. Something else that I'm sure you all know is what you do to one side you have to do to the other. This means that if I multiply the denominator by the reciprocal, I have to multiply the numerator by the same fraction. Now, this does not mean that I multiply it by its own reciprocal. I would not do this. No, 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 no. Erase, erase, erase. We don't do that. We are multiplying it by the same fraction. This guy right here. So I'm going to, in my numerator, I'm going to do 1/2 times 3/1, because what I did to one side, I did to the other. What I've done here is I've rewritten the work, so it's now a little neater to finish up the math problem. Now we're going to simplify this crazy fraction, because that is just too much for me to look at, and I don't know about you, but this is crazy. So we want our first step to be setting the denominator to 1. So I'm just going to rewrite the numerator. 1/2 times 3 over 1. And now I'm going to figure out the denominator. So to get to the denominator's value, we just multiply straight across, which gets us 3 over 3. And since 3 divided by 3 is 1, the denominator's value is now 1. Since anything divided by 1 is equal to itself, we can say that the numerator is now equal to its original self, which is our original equation. Now I want to go back to keep it, change it, flip it. Looking at this problem again, 1/2 divided by 1/3. If we kept the original fraction, the first fraction, we changed the operation, and we flipped the fraction, we get this expression in pink. Now if you look at our numerator, it's the same thing. So this example right here, putting the division expression into a fraction and multiplying by the reciprocal, is the reason that the keep, change, flip method works for dividing fractions. Here I've written another division expression, so I'm going to go through this pretty quickly before you guys try your own example. So I'm going to write my division expression as a fraction. So I'm going to write 2/3 divided by 4/3. What I'm going to do now is multiply each side by the reciprocal of the denominator. So I'm going to multiply the denominator by 3/4, which is 4/3 reciprocal. And since I did that to the denominator, I must now do it to the numerator. Okay, now that we have that, I'm going to rewrite my expression. I'm going to keep the numerator since we're first working with the denominator, so I'm just going to keep it the same for now to keep myself organized. And in the denominator, I know that 4 times 3 is 12, and I know that 3 times 4 is 12, which equals 1. So now that my whole fraction, this big fraction, is equal to 1, I know now that I can only focus on the numerator. Again, that's because the numerator divided by 1 is equal to the numerator. So I'm going to go ahead and multiply 2/3 by 3/4. I know how to simplify before I multiply, so I'm going to change the 2 and the 4 to a 1 and a 2, and I'm going to change the 3's to 1's. I'm going to multiply the little numbers straight across, and my new fraction is 1 over 2. Okay, now it's your turn. Go ahead and pause the video. Try out 4/5 divided by 1/10 with the keep, change, flip strategy I showed you, but make sure you set it up as a large fraction. 4/5 divided by 1/10. Go ahead, and I'll see you in a minute. Okay, I'm going to go ahead and show you the solution. So we're going to multiply the denominator by its reciprocal. And since I multiplied the denominator by the reciprocal, I'm going to do the same thing to the numerator. I'm going to rewrite my numerator. And I know that it's going to be set equal to 1. So now I can just focus on 4/5 times 10 over 1. I'm going to simplify. And I'm going to multiply straight across. Thank you so much for watching. I hope this video helped you understand exactly why the keep, change, flip strategy works when dividing fractions. Have a good one.